Hello guys, good day guys. We continue our lecture series from where we stopped. This is the third lecture series and we are going to be looking at data types in object-oriented programming. Now let's continue. Let's have our slides. We look at data types, operator, and basis. Now let's look at what data type is. Data types are the basic built-in operative data type provided directly by the C++ language standard. They represent the simplest form of data, such as integer, floating point numbers, single characters, and Boolean values. They serve as essential building block for constructing more complex data structured like arrays, structs, and classes. All these data types, we've seen a sample of them in the previous videos. Why? We make use of the int variable and the string variable on its int data type and the string data type. So why are data types crucial in C++? C++ is strongly typed language. This means the type of every variable must be declared, which allows the compiler to enforce the rules check. Let's look at some of these things. Also in the memory location, but then we create a data type. Understand? It's being stored. The kind of data we create, the data type signifies a lot of things about the data. For example, if we create an integer variable, normal int is what? It's 4 bytes. That is 4 bytes. 4 bytes is 32 bits in number. So it is telling us this thing is stored on the stack, and not on the heap. The memory it's being stored in the memory. The type of determine precisely how much memory storage is required. For example, yes, if we store more than the value of 4 bytes, more than 32 bits, you can see that it cannot be used for that. For example, if we store something to be short, we make use of short ints. Short int tell you is 2 bytes alone, that is 16 bits. You're not assigning value more than 16-bit variables or data in 16 bits. That's going to lead to errors and bug in our code. Also, the importance of using memory allocation, the data types enable us in memory allocation, the kind of data that can be stored in the memory. And also the data representation. You can see valid operations, the type dictate which kind of operation can be performed. By the time we are storing a very currency values, we don't need to store them in an integer value, in integer types, because some of the decimal points will not be seen. I'm going to be seeing some of them in practical demonstrations as we proceed. Let's look at some of these data types. You can see that we also have some of them negative and not negative. You can see a sample, some of it we demonstrated in previous video that we have integer is negative by default. That means it's taken, if it is 4 bytes, integer is 4 bytes. That means it's taken from what? It's taken from minus to the plus of it. 4 bytes, that will be 2 raised to power 32. But in a sign value, it will be up to what? 2 raised to power 31. 2 raised to 31 from minus or total value to the. For example, if we have this, now this is 2 bytes. Short int means what? Signify 2 bytes. Let me open my calculator. I can get it right. Yes, it's 2 raised to power, this is 2 bytes. 2 raised to power 16. 2 raised to power 16. 2 raised to 16 is what? Is 65,336. So that is for normal int. This is not, it can still carry negative values. But if we say it is 4, this is 2 raised to power 16, right? For example, now it's 2 raised to power 15 minus 1. It should be 2 raised to power 16 minus 1 because it's starting from 0. It starts from 0 to 2 raised to power base minus 1. This is what? 65,000. This is for the sign negative. For 32 for 32. Let's say for 32, 2 raised to power then we can 2 raised to power 32. We have for this, that's for 32, that's for normal int. We have it here. But that's for 32-bit, 4 bytes. So I'm going to express it now. You can get it from minus 2 raised to power from the previous one, 2 raised to power 16. Just from this, from minus d to for signed value, that's going to be 2 raised to power 16. For example, if I have used the short values to demonstrate it for so that we can easily understand it. So it's taken from the minus values minus to the plus. We can see that 2 raised to power 16, 2 raised to power 16, 2 raised to 16 give us 65, total of 65,535. But if we see that this is almost the half of this, so that means the combination of these two with this, the combination of these two, 32,768 plus 768, will give us 735 together. How is it? How is that done? Let's look at it. But you have to check that the formula, just check -1 instead of 2 raised to power 16, be able to get the lower part of it. Just okay, 2 raised to power 15. 2 raised to power 15. Let's do this way. 2 raised to power 15. 2 raised to power. Maybe 2 raised to power 15. And you see, we are starting from this. This is where we're going to start. Just -1 from it. -1 from the total bit. We have it, that is the 2 raised to power 15. Same thing for 32 here. That means if it is for signed means it can take negative number. You don't need to, once you do put unsigned in front of your integer values or double value, that means you can still take a negative values. But if you put unsigned in front of those integer, just as what we did then, that means it cannot take a negative value. For instance, now, this is what 32,768 times 2. If you multiply times 2, we have what? 30. Can you see? We get the same answer, right? That means if you add this, it's taking what? It's taking, you can still take a value from minus 32,768 until you get to 0 here. Then from 0 to what? 32,767. If you add the two together, that means it will give you the total of this. The addition of these together, not in form of remove the minus 4. Just don't consider the negative now. We give you the total of these values in number. Same thing as this as well for other type as well. If you want to get the total, the lower version of it, just firstly do this instead of 2 raised to power 16 minus 16, just do 2 raised to power 15. The double of it will give you 2 raised to power 16. With the double of it times 2 of it will give you the total of 2 raised to power 16. Just the same way. Then we can move to the next slide. Let's see application example. Use cases: loop counter, array indexing, storing quantities, bit manipulation, unsigned return. Choose base. Let's see some of these. So some of the code is chopped up. So I'll try and modify it. From this, you can see we have our what? Int here, total score is 1,500 here. Unsigned what? Int item cannot be what? This cannot be negative. Long negative this we put L, and it is you are using long values. So we are counting some of the long data. So you have to put this is long in front of it. So now let's look at the concept of data types. Floating point types represent number that may have a fractional component. They are approximately. You can also get them in your code as well. Just want to know, are these numbers even true? Are these numbers even true? Let's go back here. Let's check from our code. Are these numbers even true? For us, for example, let me firstly remove this. For example, I've cleared something there. For example, if I say, okay, int ints. Okay, let me just turn to public back for a previous video. Public this. So we can easily create our instance of the object, right? I want to get the type of this now. So we can have our dog this. Then we can now have the type. Let's print out std cout. That means our output to output something. Let's use size of dog dots age. No, it's negative. It should be what? Positive integer. Now we should get the total of 65,000 plus. Then, so this is end new line to fall into new line. Just we're going to explain them better. This is not just explaining them now. We use cout for what? To output data to the console. Then we use size of. It's a method that enables us to what? Get the size of an object, whether integer or anything you want to do. End means end into new line. This is a new line value. Then if you compile this code now, you can also run it here. If you run it here now, it's saying that what I am having what? 4 bytes. 4 bytes times 1 byte. That's multiply by 8. Well, sorry, 1 byte is 8. So we should be able to get the value of it as well. If you just multiply it, you should. Now you see we have 32 bits of data down. That's how we get the values there. So you can also see use cases, example some of the. Please, I use LaTeX to compile this as well. Some of them are chopped up for my code. You can also have bool is value, this one true, this one tape. Boolean value, you can also take either true or false. This time we can know yes or no, binary number 0 or 1 value. So now let's the type modifier. Let's see the type modifier also alters the meaning of a fundamental of data type. An integer type, char, short, int, long. So in case you want to have long data value, so we also can also assign and unsigned value to it. Also, what is the key takeaway here? C++ fundamental types are the basic building block of data representations. These are primitive data types: int, float, double, the cargo. Can also have your own reference data type or custom data type. Whether we use struct, I'm going to talk about struct in future. Whether we are using struct or we are using we used class for that. Then you can see, okay, you can also see strong data type enforce truths about memory representations, modifier sign or signs, long, floating point like our decimal places. You can use both float and double for that. Maybe in case you just want to assign some data that does not take many precisions or does not take many types. Double is double. If you want to check, also check the size of float. Float is smaller in size compared to double. Double is 64 bits, so you can check it as well. You can also have some wildcard character here, and this. I'm going to see some of this in our code in our journey as we proceed. Thank you very much. Please like, subscribe. Bye bye.